Okay, now we're going to take a look at the other free response question. So I want to kind of walk through the logic on that one as well. So this one, there's a little difference from test to test, but the general idea was the same. So the first one asked you to go ahead and graph this function. So h of 3 equals 4. So that tells me 1, 2, 3. When I put in 3 into the machine, it's going to spit out 4. So that tells me I got a guy right here. That would be this h of 3 equals 4. And now what I'm going to do is I need to say the limit as x approaches 3 from the left is 4. So what that tells me is that somehow this guy is coming up to here. I mean, it could be coming down this way, it could be coming up this way. There's a million ways that it could be. But realistically, let's go ahead and let's just say that, this guy comes like this. Kind of comes up and he settles up here at 4. So we got a curve that kind of looks like this. So that would kind of give us this piece. And then the last piece is asking me to look at the limit as x approaches 3 from the right side is -2. Now here's the deal. It's approaching -2, but we've already got a value here. So what that tells me is I have to have an open circle here, because if I had a closed circle here as well, what that would tell me is that it wouldn't be a function, it wouldn't pass the vertical line test. So again, it can look a million different ways. I mean, it can look like this. That could be it. I mean, we don't know. We just know that that's what it's going to be, something remotely like that. So now it's asking, is it's continuous? So the rules again for continuity are the following. First, does the function have a value at 3? H of 3 equals 4. It has a value. So what that tells me is that we've met the first stage. The second rule is I need to look at the limit as it approaches. I have to see the limit as x approaches 3 of h of x has to exist. And when it means has to exist, what it means is the following. The limit as x approaches 3 from the left of h of x has to equal the limit as x approaches 3 from the right of h of x. In this case, we can go right from this explanation. From the left side, it's 4. From the right side, it's -2. That's not true. That's not true. So we would say it's not continuous at x equals 3, because the limit as x approaches 3 of h of x does not exist. So that is kind of our explanation of limits in terms of continuity. So there's our first one. Every other one of these, every other one of these is another continuity-based kind of thing. So the next one is asking me, is it continuous at x equals 7? So again, the first thing I'm going to do is I'm going to figure out what is, excuse me, I'm going to figure out what is f of 7. I'm going to use this guy right here because that's where x equals 7. I'm going to say 3 plus 2 plus 7. That gives me 6. Now what I need to do is I need to check the limit to see if it exists. Does the limit exist as x approach 7 of f of x? So I got to check the left and the right. So I'm going to do the limit as x approaches 7 from the left of f of x, which is basically what I just did here. It's 6. Now what I need to do is I need to do the limit as x approaches 7 from the right of f of x. And what that is going to be is it's going to be this other function, 8 minus the square root of 7 minus 3. That's going to be 8 minus the square root of 4, which is 2. 8 minus 2 is 6. These two things equal each other. So the limit of f of x as x approaches 7 of f of x is 6. So that exists. So we've now confirmed 2 of the 3 things. The last piece is that f of 7 has to equal the limit as x approaches 7 of f of x. Do they give me the same answer? And 6 and 6, 6 equals 6. Therefore, f of x is continuous at x equals 7. Okay, so that's our next one. And then our last one, this is that one I told you was going to be on there about substituting. So now what we're going to have to do is do our rules of continuity. So the first one says we're checking continuity at 1. So f of 1 is 4 by definition. Now I'm going to go ahead and take a look at the limit. And here's again, the limit has to exist as x approaches 1 of g of x, which means I got to look at both sides. So I'm going to start here by looking at it from the left. I'm going to do the limit as x approaches 1 from the left. That's going to be this guy, cx squared, gx squared. So what I'm going to do is do my substitution. C times -1 squared. That tells me that's c times 1, which is c. And now I'm going to do the limit as x approaches 1 from the right of g of x. That's going to be this guy. So I'm going to again substitute in for that -1. And I'm going to say -1 parentheses cubed plus k times 1. So this is going to give me a k minus 1. And here's the deal. Because the third one says that the two have to equal one another, I need to know that is if c equals 4, this limit is going to equal this side. If k minus 1 equals 4, then the two limits are going to be the same. I solve for k plus 1 plus 1. K equals 5. So that tells me if c is 4 and k is 5, I've created a continuous function at x equals 1. So that was the other free response question. We'll review it again as the year goes on, because this is kind of stuff that will stick on the test. So please let me know if you have any questions. Otherwise, there's our two FRQs.